Hello to everyone, and thanks for joining today's OpenResearch Mobile Meetup. I'm very happy to join you remotely from Vienna and present the following topic to you, TCA, the Composable Architecture, or an alternative approach for a clean, modern architecture for native iOS development. Let me start with a small overview of what I would like to talk about today. So the first thing is, what is TCA? What is the motivation behind it? Who is behind it? And how was it invented? Then I want to talk a bit about other architectures commonly used in iOS development, mainly MVC and MVVM, and why the team behind TCA decided a new architecture is actually needed. Afterwards, I will talk a bit about TCA as a whole, just an overview, what are the key components, what are the building blocks, and how is it held together. And then some basic concepts in TCA about navigation, how does navigation work in TCA, what are the options, dependencies, which are actually very important in the TCA architecture, testing, which is also, or takes a huge role in the whole architecture itself. And at the end, I want to give you some pros, some cons, and some personal feelings about the architecture itself. Let's start with TCA in general. What is TCA? TCA is an opinionated architecture which was invented or started in 2018 by Brandon Williams and Stephen Seltis. What they did in the beginning is they founded a video series called Point 3, and they started doing different videos on different topics about Swift as a whole. For example, videos about SwiftUI, Swift navigation, and so on. And quickly they discovered that SwiftUI, especially in the early beginnings, had a lot of issues. So some of you might know it, especially navigation was a huge pain in the beginning. There were a lot of bugs, and they thought, okay, let's just do it better. And they started working on their own architecture to solve existing solutions. And the idea was to create an architecture for iOS which should provide consistency. So it shouldn't matter whether you are new to the team or if you work on it long term. It should be completely clear how to work with this architecture. The architecture should be easily scalable, so it shouldn't matter whether you work on a super small app or a large scale application. And a huge focus was on testability. So it should be easy to test your whole application without writing actual automated tests, for example. And as I said, the basic idea was we want to solve existing issues. That's also why TCA is considered an iterative architecture. It's constantly in development. They work a lot also with the whole community. They identify issues, also when a new Swift version drops, for example, and they try to tackle it. And through this, TCA already saw a lot of releases, and with each release, they want to fix more and more existing issues while also providing new functionalities. But before I want to deep dive in TCA, I want to give a quick overview of other architectures commonly used in iOS. So the first one is MVC, which stands for Model View Controller. This was mainly used back then when UIKit was the main UI framework. And how it works is you have your view component, you have a controller or a view controller behind the view, and then you have your model. And the model could either be a data structure or any service for API calls. So it should contain all the properties needed for the UI and also the business logic. And usually back then you had your UI or your views written in storyboards or zip files, which were just basically drag and drop UI that you configured, did the layout, and further fine-tuned it inside of the controller. And the controller itself also kept track of the whole state, and it received all the actions from the view itself. So it was responsible for receiving actions from the UI, updating the UI accordingly, calling the correct functions of the models. And because of that, the controller itself just grew very large. It was responsible for a lot of things, especially when you worked, for example, with list views or table views. The controller grew massively. And that's also one of the reasons why it was in the iOS community often referred to as massive view controller. And yeah, it was just not really scalable. And also it was not strictly separated. A lot of business logic ended up in the controller itself and not in the models. And every developer basically could do whatever he wants to do. On top of that, MVVM started being common in iOS development, especially since SwiftUI. And here we have another layer added to it. So we have the view model. We have the view itself, which is now usually a SwiftUI view. The view itself contains the information about the view model, and the view model holds the state, gets all the actions triggered by the user from the view itself, and it updates its own state, and it also triggers functionality, business logic inside the models. So the view itself should not contain any business logic. It should only send actions or functions to the view model and listen to state updates and update its view accordingly. Also with this approach, although there should be no business logic inside of the view, a lot of times if you have just a bit of functionality, it again ends up in the view itself, making it hard to maintain and also hard to test, actually. And also the view was also able to just update the state on its own. And now let's have a brief look or an overview what TCA looks like and what the building blocks are. So of course you still have your view, and the view itself contains a store. And inside of the store you have the other main components of TCA, which would be the state, of course, then a reducer and an effect. And the reducer is a function inside of the store, which is called whenever some action is triggered, for example, by the view. So the view knows, okay, there is a store and different actions are defined. For example, when the user clicks on a button. And whenever any action runs, it gets to the reducer, and the reducer is the only point which is able to actually mutate the state and run a business logic. And after every reducer state, you can either tell the reducer or the store, I'm done, everything is updated, or I need to actually trigger another function, which would be handled by the effects. But I will go into more details on the later slide. So these are the main components, but the view itself only knows the store. It can send input to the store, and it can listen to the state, which is also inside of the store. Let's have a look at the store and the setup itself. So the store, as I said, is the only thing that is bound to the view, and it basically powers the application. And it holds all the other key components of the TCA architecture. So this is one example for a store. I don't want to go into complete detail. I will also show you the code afterwards in Xcode. But the store, or my naming convention is always feature, but feature is a store. As you can see, it's just a simple struct, and inside of this store is the state, which is consumed by the view. In this example, it's just a count, which is an integer. Then you define some actions. These are actually the methods which can be triggered by the view itself. In this example, it would just be, as it's a counter, it would be an increment button. So when the increment button is tapped, a decrement button and a reset button. And then you have your reducer function. So every store consists of this reducer function. And inside of this, whenever an action is triggered, the reducer function is called. And the reducer knows the current states of the store and all the actions which are available. And it simply gets as an input the action that was triggered. And depending on the action, it can execute business logic and update the state. So the state itself, as I said, lives inside of the store. It's consumed by the view. In this example, it would be two properties, and it can only be mutated by the reducer and not directly from the view. And then we have the reducer and the effect. And as I said, the reducer is the main part of the store, and it's always running when the store receives any action. So I have shown you the actions, and in this example I added another action. In this example I have the increment button, the decrement button, a reset button to reset the counter to 0, and the button which would start the timer and after 3 seconds increment the button. And in the reducer, whenever you finish, you have to return an effect. And if an effect can trigger other side effects. So there are multiple effects you can return. The most simple one is none, which would mean, okay, I ran the reducer function, I updated the state, I'm done. Then you return none and everything's finished basically. The next one would be .run. In general, every reducer function runs synchronously on the main thread. But if you need to do, for example, an API request, you need an async context. And in this case, you can simply return .run. This opens an async context, and inside of this, you can just await for anything and afterwards mutate the state, send other actions, and so on. So .run starts an async context. Then you have another effect, which would be .send, which would mean, okay, I did what I have to do, but I will need to trigger another action. This is super helpful if you check this example with the timer. Here I would start with .run to get the async context, then I wait for 3 seconds, and after these 3 seconds what I want to happen is stop the timer and increase the counter. And I have separate functions to increase the counter and to stop the timer. So I can simply send one action increment button, which would increase it by 1, and timer finished, which would stop the timer or switch the flag. So the UI also knows, okay, the timer is done. And what you can also do when you are running something asynchronously, you can return from another action .cancel and mark this async run cancelable, which is super helpful. In this example, what I did, when the user clicks on the increment after 3 seconds button, this async await for 3 seconds would start. But if in the meantime the user clicks on the reset button, I would set the counter to 0. I would set timer is running to false, and I would simply cancel this whole effect. Therefore, the counter would be stopped and no increment of the counter would happen after the 3 seconds. I can also show this example in a small demo. So I have to switch to the simulator. So here you can see I simply built a small demo application. Here I added this counter we have just seen in these examples. And here, as I said, I have my current count and an increase button, a decrease button, a reset button, and this button to increment after 3 seconds. And also, if I start the timer and click on reset, it would immediately cancel the counter, no increment would happen, and everything is set and done. And I can also quickly show this to you, how it's connected in the code itself. So let's make this a bit bigger. So I use 2 files for this feature. I have my view itself, which is just the UI code, and the store. And using the store, I can read the current state values, for example, the counter, and what I can use is send actions. And this is how the reducer is actually triggered. And the feature itself, it contains, as I've shown you, the state, all the actions, and the reducer. And the reducer would run for each action, and when the reducer is done, it either runs another action or tells the store it's finished. Okay, let me switch back to the presentation. Okay, this showcased the basic setup. Now let me go to the next topic I would like to talk about, which would be navigation. Navigation is also very important. In the beginning I said one of the main reasons why TCA was even started was because SwiftUI navigation was very broken in the beginning. And therefore they introduced their own way of navigation, and they support two different ways of handling the navigation. One would be a tree-based navigation and one would be a stack-based navigation. A tree-based navigation means you have a feature is just a screen, for example a root screen, and the feature knows, okay, from this screen I can navigate to child feature 1 and child feature 2. So you specifically define in your parent feature, I can go to feature 1 or 2. And the child feature then, when it's pushed, also knows I can go to child feature 3 or child feature 4. So each screen and each store of the screen is responsible for the navigation targets. And in contrast to this, we have the concept of the stack-based navigation, where we have the parent or the root feature, and inside of this we have an array of other features. And the child features know nothing about their destinations. Every feature is added through the root screen, actually. So the parent feature knows I have an array of screens, for example, and when the user clicks on the button, a feature is added to this array and it's automatically pushed. And when some other button on child feature 1 is tapped, then child feature 2 would be pushed, but this also happens in the root screen. And this also makes use of one of the main components of TCA, that all features inside of a navigation stack are connected together. So as I've shown you, whenever an action is triggered, the reducer is triggered and it just goes through it. But it does not only go through its own reducer, but actually through every reducer inside of the navigation stack. That means I could have child feature 3 in the stack-based navigation example, currently present, and it could have a button which would say pop to root, and I could listen to this action actually from the root screen. So the action happens in child feature 3, but the execution happens in the root feature, and I could simply clear the whole array and every screen would pop automatically. This is actually super useful, and it fixes some of the issues SwiftUI had with environment variables. If you have ever used them, they're a bit flaky. So you can access every state of your whole navigation stack in every feature. And I also prepared a small showcase for this example. So here you can see that I added two screens, one for the tree navigation, one for the stack navigation. And at the tree navigation, I basically defined there are two possible destinations. One would be the present detail screen, which is shown as a sheet, and one would be a show alert, which simply shows a dialog. And when I click on it, it would simply show the sheet or show the alert. And in the code, it looks like this. So this is now the tree-based or tree navigation feature. And to achieve this, the feature itself contains an enum of possible destinations. And this example I've now shown you contains of one possible destination detail screen and one to show the alert. And the state itself contains of an optional destination. And if this is nil, then nothing is presented. This is the initial state. And if it is set to any enum case, then the view knows, okay, I need to show the sheet or display the alert. But there can only be one destination active at a time, and the next screen basically has to do the same setup for its navigation targets. And in contrast to that, we have the stack navigation, where we have a root screen, and then when I click on go deeper, a screen is pushed, then another screen is pushed, another screen is pushed. And how this is used is in the feature, we now don't have an enum case, which is nil or one value, but instead we have a stack state. And the stack state actually comes from the TCA framework, and it's just a list. In the beginning, it's empty. And whenever the user clicks on Go Deeper, we would simply add one more screen to the path or to this list, and it would be automatically pushed on top. So we have these actions defined down here. And as you can see, we have the Go Deeper button, which is triggered by the view itself. And it would simply append a new .number screen with value 1. And here we also make use of this delegate methods. The delegate methods are the ones that child features can talk to their parent features. And here we listen to every action inside of the path of the number features. So whenever a number screen is inside of these paths and some action occurs, this method will be called in the root screen. And here we would go also deeper. This is the Go Deeper button. And also the this number screen has an action to pop to root. So this is this one at the bottom, which goes back to the first screen. And this is also implemented here, and all you have to do is simply clear the whole list and the whole navigation stack is gone. So these are the two ways how you can do navigation in TCA. Okay, the next important thing in TCA is dependencies. TCA takes dependencies, or it's one of the base concepts, and dependencies are basically a dependency injection framework, which was also invented by Point 3. It started inside of TCA, and now it's also available as a standalone framework. And what's really nice about it is, of course, you can add your own dependencies to it, as I did here with a demo service. I simply defined, okay, I want to have a demo service in my dependency injection, or can inject it anywhere, and it has a foo method. But what you have to do, whenever you define a new service, you have to provide 3 different values for it. One is a live value, which is used when the app is actually running on the app, on the phone. Then we have a test value, which is used, for example, in unit tests. And we have the preview value, which is used when you use previews in Xcode, in SwiftUI. And this is actually super helpful because this through this you achieve test safety. Because if you do any other dependency injection or the normal dependency injection in iOS, it can easily happen that you write unit tests and you inject your service, for example, an API client, and you forget to do a test or mock implementation, and your tests actually use the real API. And this can't happen here, because if you write a test for this service and the test value is not implemented, the test will fail. So this is actually super nice. And to inject it anywhere, you simply have to write add dependency and the name you defined for your service API client, and it automatically gets injected. And what's also super nice is, I will showcase this as well, each service can easily be overwritten at runtime. So everywhere in your app you can define, okay, I will now push another screen, and for this screen I don't want to use the live value, I want to use a mock implementation. For example, if you have an API client and you push a screen as an onboarding to the user, and you want him to experience the feature completely without doing any API requests, you can simply tell the store, don't use the live value while you are in the onboarding context, use the test value with the mock implementation, and the user can easily play around with it without doing actual API requests. So to showcase this quickly, I added a second tab, which is just a login. And before I show you the login itself, let me go to the login service. This is the one I added to the dependency injection. and my service contains a three methods: log in, log out, and is logged in. And I added, of course, as I've shown you, the live value, which defines that the username and the password needs to be test. And then I just added mock implementations for test and preview value. And this service is now used in the login screen. So this one should have now the credentials test and test. Let me first enter incorrect credentials. It fails, very good. And now we will use test and test. And now it should succeed. Yes. And I also automatically navigate back. And on the profile tab, we should see I'm logged in. And to showcase how easy, or let me first show you how the service is consumed. So we have the login feature. This is the whole magic to inject it into your store. So you can simply write add dependency with the name you defined, in this case login service, and then you can use it. And then I added another button, alternative login, where I defined the login credentials should now not be test, but instead it should use test2 and test2. And when actually opening this alternative screen, what I'm doing is below in my body, I simply need to define whenever the login feature from this alternative login action is triggered, I want to override the login service dependency with the alternative implementation. So you can override the whole dependency for the whole feature, also for the child screens of the feature, which is actually super nice for a demo implementation or an onboarding flow. And here with test and test, the login would fail, but instead you have to enter test2 and test2, and then we should be successfully logged in. Very good. Then let's go to the next topic, also the last huge topic. It's about testing, and I quickly want to show you how easy it is to test the whole functionality. So how testing works with TCA is for each store, or you can initialize each store inside of a test store in your unit tests, and then simply send actions to the store and check for the state mutations and for the results. And of course, it's also super easy to just override dependencies in your tests as well, the same as in the during the runtime itself. So I wrote one test for my counter feature, and what I did, so the first thing is I just used test clock, which is also provided by this dependencies framework from point 3, and I override the clock dependencies using this test clock, and this just enables me to later advance by 3 seconds without actually waiting in the test case. But the important thing is I'm initializing a test store with my counter feature, and afterwards I'm simply sending my action increment button tapped, and then I can immediately check, okay, the increment button was tapped, now I expect the count to be 1. Then decrement button tapped, count should be 0. Increment timer button tapped, is timer running should be true. Then I advance by 3 seconds, and after 3 seconds I should receive this increment button tapped, so the counter should be increased again, and timer should not be running anymore. And if anything happens, so for example, if I would change this increment button tapped call here to count equals 0, the test would fail. If I add a dependency inside of my feature, which has no test implementation, the test would fail. So it's super easy and super extendable actually for testing your whole business logic of the application. Okay, now I want to quickly go over some pros and cons. In my opinion, the pros are pretty clear. The testability is just great. So when you're writing code using MVC or MVVM, it often happens that you have different developers, everyone works a bit differently, business logic ends up partially in the view model, partially in the view itself, and it's not easy to test. And with TCA, you have a clear separation of concerns, and you can really focus on testing your whole business logic without writing any UI tests. Then the consistency, the features are always built up the same, and together with that, the scalability is a huge factor in my opinion, because of course these were small features, but if you have a large screen with a lot of logic, it is also super easy to just split it up into smaller feature packages or smaller stores, because as I've shown you, the parent store always knows what's happening in the child stores. So you can also add 4 different stores on one screen, and you have a root store and 4 independent stores for each section of your screen. And in the root store, you handle whatever is interesting for everything, and specific parts you handle in the separated stores. So this makes it really scalable and super easy to use once you get used to it. And yeah, with this comes also the point with the clear separation of concerns. The view is not even able to update the state. And because of this, you can't end up with business logic inside of your view. And also the support. The community is pretty big already. Also, the 2 guys behind it are super responsive. There's a Slack community as well you can join for free, and you can just ask questions and you will always get answers very quickly. So this is super nice. And also when new Swift versions arrive, they are super fast with adopting to it and making TCA work with it as well. And the cons, in my opinion, are the learning curve. It's a bit weird in the beginning. Also, I simply scratched the surface, but there are a lot of details you need to know, and it just takes some time to really know how to work with it. Of course, also another advantage is a boilerplate code, because if you have really small features, really small screens, it will just bloat them a bit, because you have to do every store setup the same, independent of the size of the feature. Also, one of the cons is compile time, because TCA uses macros heavily, and how macros work in iOS is it's just adding code in the background basically. And if you have a lot of features with a lot of macros, it will add a lot of code and it will slow down your compile time. This could also be interesting if you have a super large scale application. And of course, it's still a third-party dependency. So yes, the support since 2018 until now is great. Also, the community is great. But if you plan to start on a new project and want to work on it for years, you have to consider what happens if the support stops. What happens if a new Swift version comes out, TCA is not compatible with it, and there is no official support for it anymore. Then you are a bit stuck. So you should always keep this in mind and be careful when thinking about large-scale or long-term applications. Yeah, that's basically it. Maybe just as a few last words. I hope you have you got a small overview. As I said, I just scratched the surface, but I can really recommend, if you're interested, to just check out point 3. Also, there are other frameworks which were built out of TCA. For example, dependencies, you can use it without using TCA. So they have a lot of great stuff, great video series, and I can really recommend to give it a try. Thanks a lot.